These are notes from Mel Hom'S Math 251, section 5.5. All right, so we're doing substitution. Look for a function and its derivative. So we did some last time. Some more problem 11. The original was the integral of cosine pi over 2t dt. So I would like this to be u, so let u be pi over 2t, du is pi over 2 dt. So that means I need to have a pi over 2 inside. So I multiply by pi over 2 inside and 2 over pi outside to balance that. That way I'm multiplying the expression by 1. Now the next step, I'm going to change this to u. I'm going to change this pi over 2 dt to du. So I, which will mean my original integral, is now 2 over pi integral of cosine u du. Okay, and integral of cosine is sine, so 2 over pi sine u plus c. Just change u back. So final answer, 2 over pi sine of pi over 2t plus c. And you may notice if I differentiate this, it works. The derivative of this would be 2 over pi cosine pi over 2 times pi over 2. The pi over 2 would cancel 2 over pi, and I have the original back. And of course, the derivative of any constant is 0. 15, the original has cosine cubed theta sine of theta. The derivative of cosine is negative sine. Derivative of sine is cosine, but you have a cosine cube. That's too much. So let u be the cosine. You're going to end up with u cubed, but that's okay. So let u be cosine theta. Du is negative sine theta d theta. That means I need a negative 1 inside and a negative 1 outside. So negative sine theta d theta is my du. This becomes u. So I have negative the integral of u cubed du. Negative u to the 4th over 4 plus c. Change u back. So negative 1/4 cosine to the 4th theta plus c. Okay, double check. What's the derivative? Well, the derivative 4 knocks out the 1/4, so you have a negative cosine cubed times the derivative of cosine, which is negative sine theta. That negative would knock out that negative, and I have my original of cosine cubed theta sine theta. So it works. Problem 21. Integral of natural log of x squared over x dx. Okay, the derivative of natural log of x is 1 over x. You don't see a 1, but you can sneak in a 1. Okay, so let u be natural log of x, du equals 1 over x dx. So that way this becomes u. All of this stuff here is du. So my integral is u squared du, which is u cubed over 3 plus c. Change u back to what it was. So 1/3 natural log of x cubed plus c. Quick double check. What's the derivative of this? 3 times 1/3 cancels out, ln x squared. Then by the chain root times the derivative of the inside, 1 over x. So it works. 31 is pretty much tailor-made. The derivative of arctangent is 1 over x squared plus 1. So u equals arctan x. Arctan, by the way, means the same as inverse tangent. Du is 1 over x squared plus 1 dx. So I change that to u. 1 over x squared plus 1 is du. So I have the integral of u squared du, u cubed over 3 plus c, and then change u back. So 1/3 arctangent of x cubed plus c. Double check by differentiation. The derivative of this guy is 3 times 1/3 is 1, arctangent x squared, then by the chain root times the derivative of the inside, which is 1 over x squared plus 1. So it works. 41, the integral of cotangent. Well, cotangent is cosine over sine. And I see the derivative of sine is cosine. By the way, the derivative of cosine is also sine, but you don't really have sine. You have 1 over sine. So that leads me to believe I should let u be the sine of x. Du is cosine x dx. Oh yeah, I'll have a u on the bottom, but that's okay. I'll have du on top, u on the bottom. So du over u, that's like 1 over u du. That's my natural log. So natural log absolute value of u plus c, and change u back to sine. So final answer, ln absolute value of sine x plus c. Double check by differentiation. The derivative of this is 1 over sine x times the derivative of sine x, which is cosine x. So you have cosine over sine, which is cotangent. Okay, Now I'll show you what happens for definite integrals, introduction to that. It's a little bit different, but not too bad. Okay, integral of cosine pi over 2t dt, and t goes from 0 to 1. I'm emphasizing I put t equals, and you say you never wrote that before, but I'm writing it now to emphasize that the 0 and the 1 are for the variable t. Okay, then I'll do my u substitution, that u equal pi over 2t, du equals pi over 2 dt. So that's the same as usual. Okay, I need a pi over 2 inside, 2 over pi outside. Now, however, t is going from 0 to 1. When t goes from 0 to 1, what happens to u? So what I do is I plug in. I plug in t equals 0 right here, and 0 times anything is 0. I plug in t equals 1, I get pi over 2. So that means as t goes from 0 to 1, u goes from 0 to pi over 2. So I change the limits also. So in other words, I change t to u, I change dt to du, and even these limits, which are for t, go to different limits perhaps for u. So my new integral is 2 over pi. I no longer integrate from 0 to 1. I'm now integrating from 0 to pi over 2. Cosine of u du. Okay, there it is. So now the whole problem is in u. This is u, this is du, these are u. I don't have to go back to the original t anymore. No need to substitute back. Okay, so integral of cosine is sine. So 2 over pi sine of u from 0 to pi over 2. 2 over pi sine of pi over 2 minus sine of 0. Sine of pi over 2 is 1. Sine of 0 is 0. So final answer is just 2 over pi. Okay, then one more like that. 55, integral from 0 to 1 of cube root of 1 plus 7x dx. Okay, I don't like cube root of 1 plus 7x. I like cube root of u. So let u be 1 plus 7x, whose derivative is 7. So du equals 7 dx. So I need a 7 inside and a 1/7 outside. Okay, and the 0 and the 1 are for which variable? X. So I need to see what happens to u. So I plug in x equals 0, put a 0. U is 1 plus 0, which is 1. Plug in 1. 1 plus 7 times 1 is 8. It's a 7 there. So as x goes from 0 to 1, u goes from 1 to 8. So my new integral isn't going to go from 0 to 1. It's going to go from 1 to 8 because u and x are related by this. So my integral becomes 1/7 integral from 1 to 8 of cube root of u, and then 7 dx is du. So I have u, du. These numbers are for u. I don't need to switch back to the original x anymore. Okay, so that's u to the 1/3. Integrate u to the 4/3 divided by 4/3 means times 3/4 from 1 to 8. So that gives me 3 over 28, parentheses, 8 to the 4/3 minus 1 to the 4/3. Okay, well, 1 raised to anything is 1. 8 to the 4/3 means cube root of 8, 2, and then raises to the 4th power, 16. So 16 minus 1 is 15. 3 over 28 times 15. Final answer is 45 over 28. Okay, so these are how to do some more problems in 5.5. And I'll do some more tomorrow, hopefully. Let me give you the focus thing here. All right, so that's as much as I wanted to do for Math 251 extra work in 5.5.